us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Goal 1. Differentiation. 1.1 Find the equation of every tangent line to the curve y equals e containing the point -1, 0. This is not a point on the curve. 1.2 Let a and b be positive real numbers. Find the equation of every tangent line to the ellipse with implicit equation containing the point 2a, 2b. This is not a point on the ellipse. 1.3 Let a be a real number different from 0. Use the definition of the derivative as a limit of difference quotients to find the derivative to the following function. At the point x equals a. 1.4 Use the definition of the derivative as a limit of difference quotients to find the derivative of the following function f x equals tan x at the point x equals 0. You may use without proof that the following limits exist and have the given values. mathhomeworksolver.com. 1.5 For x greater than 0, let f x be the function, thus the inverse function satisfies the equations e square root y equals x and square root y equals ln x. Compute the derivative. Goal 2. Sketching graphs. 2.1 Sketch the graph of the function. 2.2 Sketch the implicit function. mathhomeworksolver.com. 2.3 Sketch the graph of the function. Goal 3. Applications of differentiation. 3.1 A sculpture has the form of a right triangle. The material used for the vertical leg has twice the cost of the material used for the horizontal leg. The length of the hypotenuse is fixed, thus its cost is irrelevant. What ratio of vertical leg to horizontal leg minimizes the total cost of the material? 3.2 A farmer has a fence running diagonally across her property at a 45-degree angle to the north-south and east-west lines. She decides to build a corral by adding a length b- of fence running north-south, a length b- of fence running east-west, and then connect the two corners with two length b of fence running north-south and east-west. Thus, the total new length of fence needed is 4b-2a, and the corral has the form of a square of length b, with a small isosceles triangle of leg length a removed from one corner, where the square corral meets the pre-existing diagonal fence. What ratio of A to B gives maximal area of the corral for a fixed length of new fence? mathhomeworksolver.com. 3.3 An icicle has the shape of a right circular cone whose ratio of length to base radius is 10. Assuming the icicle melts at a rate of 1 cubic centimeter per hour, how fast is the length of the icicle decreasing when it is 10 centimeters long? 3.4 A cube of ice rests on the ground. The cube of ice melts at a rate proportional to the surface area of the cube exposed to the air, thus, the area of the 5 sides other than the side sitting on the ground. Assuming it takes 5 hours before the volume of the melted cube equals 1/2 the initial volume, how much longer does it take for the cube to melt entirely? Goal 4. Integration. 4.1 An integrable function f x is defined on the interval 0, 1. Give the formula for the Riemann sum of f x on 0, 1 with respect to the partition of 0, 1 into n subintervals of equal length, evaluating the function f x at the right endpoint of each subinterval. 4.2 Let r be a positive real number. Use your formula for the Riemann sum to reduce the following limit to a Riemann integral. Then evaluate that Riemann integral using whatever integration technique you like and determine the limit. mathhomeworksolver.com. 4.3 Use your formula for the Riemann sum to reduce the following limit to a Riemann integral. Use an inverse hyperbolic substitution to evaluate the Riemann integral and determine the limit. You are free to use the following formulas. See also problem 6.1. 4.4 Compute the following integral. Hint: it is not possible to write down the antiderivatives of either of the separate integrands. 4.5. Compute the following integral, mathhomeworksolver.com. Goal 5. Applications of integration. 5.1 Denote by the unique angle in the range 0a pi/2 satisfying. Compute the area bounded by the curve y equals tan x minus pi/2x pi/2 and the tangent line to the curve at x, y equals minus pi/4 minus 1. 5.2 Find the unique, positive value of h making the area of the region bounded by the parabola, and the parabola, equal 1/2 the area of the region bounded by the parabola. And the parabola mathhomeworksolver.com. 5.3 Let a and b be positive real numbers. Find the volume of the solid obtained by rotating about the y-axis the region in the first quadrant of the xy plane bounded by the x-axis, the y-axis, the line x equals a pi and the curve y equals b sin x/a. You may use either the washer method or the shell method. 5.4 Compute the arc length of the segment of the curve y equals ln x bounded by x, y equals 1, 0 and x, y equals e1. At some point, it will help to make an inverse substitution. You may make either an inverse trigonometric substitution or an inverse hyperbolic substitution. The resulting integrals are comparable. See also problem 6.2. 5.5 Compute the area of the surface obtained by rotating about the y-axis the segment of the curve y equals ln x bounded by x, y equals 1, 0 and x, y equals e1. At some point, it will help to make an inverse substitution. It is best to make an inverse hyperbolic substitution. You are free to use the following formulas. mathhomeworksolver.com. See also problem 6.3. Goal 6. Techniques of integration. 6.1 Do the inverse substitution part of problem 4.3. 6.2 Do the inverse substitution part of problem 5.4. 6.3 Do the inverse substitution part of problem 5.5. 6.4 Compute the following antiderivative. Hint: use the half-angle formula and integration by parts. 6.5 Compute the following antiderivative. mathhomeworksolver.com. 6.6 Compute the following antiderivative. 6.7 Compute the following antiderivative. Goal 7. L'Hospitallesse rule. 7.1 Compute the following limit. 7.2 Compute the following limit. 7.3 Try to find non-zero, analytic functions f, x, and g, x, defined near x equals 0 such that f, 0 equals g, 0 equals 0 but does not equal 1. Remark: don't try too hard. No problem on the final will ask anything this vague. Also, functions f, x, and g, x, satisfying the conditions do not exist, smiley face. mathhomeworksolver.com. 7.4 Denote. And denote, compute the limit. 7.5 Compute the limit. Goal 8. Improper integrals. 8.1 Determine whether the following improper integral converges or diverges. If it converges, evaluate it. 8.2 Determine whether the following improper integral converges or diverges. If it converges, evaluate it. mathhomeworksolver.com. Goal 9. Taylor series. 9.1 Compute the Taylor series expansion about x equals 0 of f(x) equals ln 1 plus x. 9.2 Let a minus 1 be a real number. Compute the Taylor series expansion about x equals of f(x) equals ln 1 plus x. 9.3 Let a be a real number. Compute the Taylor series expansion about x